Hi there, and thanks for tuning in. I am TexasTim.dev, and welcome back to my ongoing quest to grind through all of the LeetCode algorithm problems. I've done all the easy ones, although sometimes, LeetCode posts a new one, so I pick that one up. But mainly, I am working through the medium problems, and I'm about 20% of the way through the medium problems. And I've only done like 3 of the hard. So I'm working my way upward in terms of complexity and difficulty. Well, without further ado, let's see what we have today. Let's go over to problems. And choose algorithms. Let's see if there's any easy ones that might have come in that I haven't done yet. Ooh, there are a couple. Why don't we pick one of these up? Ooh, check if string is a prefix of array. Even without seeing the description, when I see prefix, I think a tree structure, TRIE, short for retrieval. Although it is very confusingly pronounced by most people the same as tree, like a binary tree or a red-black tree. I think some people call them tries sometimes, although traditionally, from what I understand, they were pronounced tree after retrieval. Well, let's do it. I've talked enough about it. Let's get in there. Okay. Easy. I am logged in, right? Yeah, I'm logged in. Check if... it's asking me to favorite, I see. No. Check if string is a prefix of array. Given a string, S, and an array of words, an array of strings in an array called words, determine whether S is a prefix string of words. A string S is a prefix string of words if S can be made... If S can be made by concatenating the first K strings for some positive K. Well, that made it a lot easier if it's in order. If it was just going to be, it could, pick willy-nilly from anywhere in the array. That's a lot harder. But if it's in order, I feel like that's going to make it a lot easier. All right, let's see. Return true if it is. So let's look at the examples because it's not quite gelling for me. I love LeetCode. The words are I love LeetCode apples. The output would be true because I love LeetCode. All right. And here apples is first. So I'm kind of thinking like some pointers and then kind of like a pointer into S, and then a pointer into the array, and then doing some kind of a substring comparison, checking to see if S contains the next word and no larger than word's length. So it could be all the words, or it could be fewer than all the words. There could be 100 words in the array. Each word is 20 or fewer characters. All right, I think we can do this. I'm feeling confident. Only lowercase English letters. Well, why don't we get in there? So we're going to have an index into S, which will start at 0. And then we'll have an index into words, which will also be 0. And what I'm thinking is we'll do an early return if we ever detect that there's a mismatch. And the mismatch would be that we've got a string or a substring, let's say a substring of characters in string S that don't match the current value, the current element of the words array that we're on. So if we're on the 0th element of words, we're looking for, for like example 1 here, we're looking for I, and it has a length of 1, so we're going to be looking at S from 0 to 1, because the index would be at 0 for that first one. All right, I think we can kind of hang it together. I'm not completely clear on how I'll want to stop when I hit the end of string S, or when I hit the end of words, and so I'm going to have to include that in there. So we'll see how that goes. How about for now, let me do while, and I don't know what that condition will be. I'm thinking we'll return false from inside the while if there's ever, we'll return false if we detect, a mismatch, or we could return true from within. Or then again, the condition here could be something to do with the pointers. The pointer into S would have to not exceed the length of S or something. Why don't we start coding it, and maybe it'll become more clear, because I'm not exactly sure how to set that up in kind of an efficient way. Although, to be honest, I'm thinking less of efficiency and more of kind of clarity and readability, because there's several different possible ways that the loop could have to be broken, or we'll have to return. All right, let's get into it. Ooh. So the index into S will be the beginning of whatever substring we're checking. Let's do length of current word equals words, index into words, length. Now, one check we could perform is if the length of the current word is longer than the number of letters we have left, in which case we would return false. So check if current word is too long for remaining string S. And that's easy to check for if this is greater than, let's see, S length minus index into S will give us the number of characters left. So if S has a length of 10 minus 0, there's 10 characters left. If the length of the current word is 10, then that needs to work. Oh, wait, we're seeing if it's too long. So yes, if it's greater, it could be equal. Equal would be okay. That would mean, we're going to end exactly on the boundaries of the end of S and the end of the current word in array words. But if the length of the current word is greater, then it exceeds it. So we would return false in that case. All right. Hey, look, one condition down. So if we reach this point, then the length of the current word is shorter. Might not be correct, but it is shorter. So let's see if there's a match. So I think we'll do if not We'll do words. Make sure it's grab that guy. If the current word is not equal to the substring from index into S to index into S plus, man, there's a lot of offset arithmetic here. I'm gonna need more room. There we go. So if the current word, and maybe for clarity, current word in words, just for the clarity of it. And then, there we go. Current word in words, length of current word. So if the current word, oh my goodness. So if the current word in words doesn't equal the corresponding substring in S that has that same length as the current word, then we return false. Not a match. Same length, we'll say. Okay. All right, so if it passes this check, then at least it's possible. You know, the length of the word could fit into the remaining characters of S. Here we're seeing if it actually matches. So if we reach this point, then we have a successful match. So now I think now we'll update the index into S. We'll update that by the length. Okay. And I think we'll also update the current index into words. There. Incrementing that by 1, we're just going to the next word. So now we can check if we've reached the end of either one. So let's check first, see if we've reached the end of string S. If index into S equals the length of S, then we have reached the end of S and we have matched all the words so far. So we can return true. That's a successful match. Now, if we haven't reached the end of S, but if we've reached the end of words, then in this case we would return false because we've run out of words and yet we have not yet reached the end of S. So if index into words equals words.length, then we have run out of words And we have not yet matched all the characters in S. So here we're returning, so actually we'll return from within loop. I imagine there are some coders who would balk at, returning from inside this while loop, and then me having to put, return false, and then shouldn't reach here. Will return from within while loop above. I'm sure there's some coders who are like, that's sloppy stuff there, buddy. Okay, let's look and see if we made any dumb mistakes, like forgetting a semicolon or mixing up a variable name. It's been known to happen. Let's say update pointers, I guess. Well, not really pointers. Update indices. Okay, I think we can run it. Unreachable. Oh, okay. So it's not going to care. I like it. Okay. It worked there. Let's put in this next test case. See what it does. That also works. Moment of truth. Let's hit submit. Yeah. Woohoo. That makes me happy. All right. Now, not the super fastest code ever. Sometimes that's just the luck of the draw. If, other people are submitting at the same time. Let me try running it again. See, look, a little bit faster. A little bit faster, but still the same. No better than 66%. Let's take a look at the graph here, which might not have enough people yet. Oh, look, everybody's up in that first category. Nice. Oh, look, string builder. Oh, that's funny. I guess that's a good way too. Just keep adding each word and then checking to see if it matches. I mean, that's pretty good. I guess mine is a little bit lower level. I'm kind of, very manually doing this, substring comparison. It's interesting. But mine works. And I will say that, let's take a look at that example. The example of the faster one. Let's take a look at it real quick. I'll just do a couple of comments and then I'll end the video. So they got a nice, what's this? Oh, okay. Got a nice little guard clause here. I feel like that's not necessary because I don't have that same kind of guard clause, and yet mine was accepted. But here they're saying if the first word is longer than the whole length, well, then the length of string S, then return false. That feels like a very tailored guard statement to a particular test case. I wonder if I include that, is that gonna boost my score? Let's see. Am I gonna get a little bit faster? Look at that, I went down to 0. Let me take that out. Let's back up to 2. Wow, that is really interesting. How many test cases are there? 346. For some reason, including this little check of whether the first word in the array is longer than the whole string S. Just that one particular check seems to be making a difference. That is odd. I wonder how that person came up with that. Well, I suppose I could keep it. Let's see. Very special guard clause. I'm not going to put very special, that's silly. I'll put that there. I did get a 0 at one point. I do like to kind of record whatever the fastest time was, just to get a sense of, you know, how certain how certain algorithms and code combinations work. Cool. I'll notate the little bit smaller memory footprint too. Well, thanks y'all so much for hanging out and coming along on solving this little problem. Not too hard, but certainly fun, and you know, gives you a lot to think about as you go through in, you know, kind of basic coding practices and stuff. Anyway, I'm sure glad you joined me today. And if you would like to find out about the next time I upload a video, YouTube gives you several ways to stay on top of that kind of information. There's a little bell that you can click. There's a subscribe button. There's a like button. Any combination or all of those will definitely help you to stay informed. If you've got any suggestions for maybe another aspect of this particular challenge that you thought I should have brought up, or any critiques, if you have anything you want to suggest as a point of improvement, hop on down to that comment section below and let me know. I read all the comments. I respond to most of them. I'd be happy to engage with anybody down there. Well, until the next time, thank you so much, and see you later. Bye-bye.